Now, in this lesson, we're looking at the axes of symmetry. Now, an axis of symmetry acts like a reflection line or a mirror. Let's look at some examples to illustrate the point. Now, we're asked to draw in the axes of symmetry for each shape below, starting off with a square there. Now, if we folded, pretend it was a piece of paper, if we folded this square right down the middle there and thought about the left side and the right side and folded it over, folded it across that line, we would find that it would fold exactly on top of the other side. Hence, that's an axis of symmetry, that line drawn. What if we draw a line directly across it and think of the top and the bottom and fold downwards? So let's fold the paper. Again, it folds directly on top of the other. So they are examples of axes of symmetry. Now in a square, that diagonal and that diagonal, they're also axes of symmetry, because if we were to fold them, they would fold exactly onto the other side. Now what about a rectangle? Well, what about a diagonal? Do you think that might be an axis of symmetry? Certainly looks it, because it seems to cut it exactly in half. But in terms of folding it, let's see. If we consider the top and the bottom, and we fold it down, well, you can actually see that it doesn't fold directly on top of itself. So in fact, the diagonal is not an axis of symmetry. Let's get rid of it. In a rectangle, straight down the middle, yep, that's an axis, as is if we go directly across. So those two are axes of symmetry. Now this shape, can you remember what this is called? This is called a parallelogram. If we think of the diagonal there and fold that again, if we fold it down, much like a rectangle, it doesn't fold on itself. So let's get rid of that diagonal, it's no good. In fact, if you were to cut it out, a piece of paper in a parallelogram shape, no matter how you folded it, right, you will not find an axis of symmetry. There are none there. Now this shape is called a kite. Its axis of symmetry straight down the middle. Alright, there are other different shapes, often letters. Often letters have axes of symmetry. Can you think of where the line should go there for the axis of symmetry? Did you say that? Right down the middle? Now what about a circle? Okay, if you cut out a circle and tried to fold it on top of each other, well, if we drew a line straight down and folded, we get that as an axis, as we would directly across, and diagonally, and diagonally. And in fact, any line that you drew through the circle's center and then folded it, you would find they would be in an axis of symmetry. So we say that a circle has an infinite number of axes of symmetry. Excellent. Well, that concludes the lesson. Good luck with your questions.